Hi, welcome to Lumora University. My name is Snigdha, and today I'm going to be teaching kinematics. So, first of all, let's go over the definition of kinematics. It is the branch of physics that describes the study of objects in motion, and the three or four main topics that are introduced when talking about kinematics are distance, displacement, velocity, and acceleration. So we're going to discover a few formulas about those four topics, and we are going to learn their definitions. Okay, so first let's start with distance. So in physics, distance is the amount of meters traveled between two places. So let's say you start over here. This is point A, and let's say this is point B. So you could go however you want. You could go like that. And after you get to point B, let's say all of the scribble that you did over here, let's say that distance D is equal to 100 meters. That means that while going in all these loops and traveling back and forth, by the time you went to point B, you traveled 100 meters. And in physics, it is really important to remember that usually you should be measuring distance, especially in its SI units, which is the standard units that is used in most curriculum. And for distance, that would be meters. And you might have noticed that distance is only focusing on the magnitude and not really focusing on the direction, which means that it is a scalar quantity, which is really important to remember. So again, the definition of distance is the amount of meters traveled between two points in physics. And now we will talk about displacement. Okay, so now displacement. So a really common misconception is the that thinking that displacement and distance are very similar or that they are the same thing, and that is not at all true. So let's take the same example that we used for distance. You have point A, and then you also have point B. So let's say you go in like a really weird loop, try going back and forth, and you get to point B. So now, in the same example that we did before, we know that traveling all of this over here takes us 100 meters, right? So this is the distance, and that is very clear. However, displacement only focuses on the distance between point A and point B. So let's define displacement as the variable x, right? So the variable x, we can say the point A is the initial x. So let's say, let's not use O, let's use I. So x sub I, and point B is x sub f, which describes the initial displacement. So let's just say we're starting at 0 meters and then we end at 10 meters. So that means that the actual distance, if you drew a horizontal line like this, the shortest distance between point A and point B, that distance would be 10 meters. And that means that we are defining displacement. So x is equal to xf minus x naught. So that means if a person were to travel this path and go back and forth like this, they would travel a distance of 100 meters, but the actual displacement that they would make would only be 10 meters because that is the distance between the final position and initial position. So to make sure that this difference is understood, let's go over a few example problems. Okay, so let's do that. Okay. So let's take our first example problem. We can still use the example of our points, but in this case, let's just say you start walking from home and you're trying to get to school. Let's say in the middle, you have to go by the park. And right in between your home and the park is the school. Okay, so now the only way you can get from your house to the school is to take a roundabout loop like this. Okay, and we're going to define your position at home at x naught or x initial is equal to 0 meters. And remember, we're always using meters because it is the standard value for physics, usually. And then at the park, you're at, let's just say x. So x is equal to 10 meters. And in relation to the 0 meter mark right here, so if it helps, you can draw like a little dotted line going over there. So the distance from that point from there is only, let's not say 5 because that's not exactly in the middle. So let's say it's 4 meters. Okay, so we're going to say xf is equal to 4 meters. So now the first question is, what is the displacement made from your house to the school? Okay, so now you know that the final position is xf is equal to 4 meters. So if you say your displacement is delta x, because you're always trying to find the difference in, so delta x is equal to xf minus x naught. That is our equation for the displacement. And now we substitute our values. We know that xf, oh, no. Okay, so we know that x F is equal to 4 meters and that x initial is equal to 0 meters. So that means that your total displacement is equal to 4 meters. Okay, so now we know that it's always going to be the distance between the final position and the initial position. Okay, so now let's talk about the distance that you traveled from your house to the school. Okay, so let's erase our steps over here real quick. Okay, good. So over here in this example problem, I gave you the value for the distance that you traveled from your house to the park. And now you don't really know what the distance is from your park to the school, so let's just define that as x is equal to 20 meters. Okay, so now if you say distance is equal to um, the distance between the park, so park minus x naught, right? So that's the first round you make, plus 20 meters. Okay, so that's how much it takes you to travel from your house to the school. Okay, so now if you were to calculate that, you would get 10 plus 20, which is equal to 30 meters. So over here, you can clearly see the distance, the difference between calculating the displacement and the distance, because even though they sound very similar or people might confuse them, the values that you get for um, each definition can be very different. So it's always important to remember the difference between the two. And now we can move on to velocity and acceleration. Okay, so first let's talk about velocity. Velocity is, okay, so your first question might be, what is the difference between velocity and speed? I mean, when we were growing up, a lot of people might interchange velocity and speed, and you might be like, okay, what's the difference? And in physics, that difference is very, very big. Speed, so let's talk about speed first. Speed is just how fast you're going. Like, let's say you're in a car, right? You have a nice car like that. Um, and you're in the front seat and you see that the car is going, okay, 10 miles per hour, right? You're driving kind of slow. It doesn't matter whether you're going backwards or you're going forward or you're turning left or right. You're always let's say you're always just going 10 miles per hour. That value doesn't really change and the direction isn't really significant. So that means that the speed is a scalar quantity because it only talks about the magnitude and not the direction. So this is the magnitude, and the direction would be, okay, am I going backwards or forwards or something like that, which is insignificant for speed. But velocity, on the other hand, does care about the direction you're going in. If you were talking about a car you're building or it's a science project, and your teacher might ask you, okay, what's the velocity of the car? The velocity would change in direction. I mean, in accordance to the direction, whether it was going forward or backward. So let's say you define the car going forward as the positive direction and the car going backward as the negative direction. And let's say this car is also traveling 10 miles per hour. If it was going forward, you would say the velocity of the car would be positive 10 miles per hour. But let's say it's going backwards, then you would say, okay, now it's negative 10 miles per hour. So in velocity, the direction is really important and it can change a lot of your calculations. So now we're going to talk about how we usually measure velocity in physics. Okay, so the standard or SI units for velocity is meters per second, and that's very important to remember because you might get that in a few tests or anywhere in general. So really, it's really important to remember meters per second is always how you measure your velocity. So an example might be, okay, so the car is traveling at 10 meters per second instead of using miles per hour. And then sometimes you might have problems that give you uh, different units and you'd have to convert it back. Okay, so now let's cover a little deeper into velocity. So we don't need to worry about speed anymore for now. Speed is a very basic thing and you won't usually come across it in kinematics. So now for velocity, let's focus on average velocity. In kinematics, the average velocity, or it's also written as, you can also see it written like that. So the average velocity is given by the change. So the delta it represents change in. So change in displacement divided by delta time. So change in time it gives you the average velocity. And when you see the word average, you might also think of the average value or the mean. So that's why another equation for the average velocity might be given as v1 plus v2 divided by 2, or oh, that's a really bad 2. um, by 2. It can also be V naught or VF. It really depends on the problem given. But the most important formula for average velocity would be delta displacement by delta time. Okay, so now let's cover an example problem for average velocity. And this is probably one of the most um, frequent problems you will see for average velocity. Okay, so this is an MCQ style problem. Let's say I tell you an, an object is traveling for t is equal to 10 seconds from an initial displacement of x initial is equal to 0 meters. It, okay, that's not, okay. It stops at xf is equal to 10 meters. What is the average velocity of this motion? Okay, so now we're going to use a method called the guess method. Okay, so let's do this. So the guess method stands for G is your givens. So in this situation, you know that t is equal to 10 seconds, right? And then your x initial, so that's where the object started. So that is equal to 0 meters. And then your x final, so that's where your object stopped at 10 seconds, that's where it is. Your xf is equal to 10 meters. Okay, so now your unknown is what you don't know, what you're trying to find is v average, right? So that's your question mark. Okay, so let's erase this so we have a little bit more space. Okay, delete that. Make sure that you got all of that written down. So now E stands for your equations. And what equation is that you have your unknown values and you have your given values. So now you have to find an equation that you know of that that can give you your unknown value using the values that you already know. And in this situation, we just discussed the equation for average velocity. So that would be V average is equal to delta. Okay, since we define displacement as x, we're going to say delta x by delta t. Okay, so now the S stands for steps. In this situation, there isn't a lot of steps, but if you're just beginning kinematics and you want help remembering what you should define delta x as and what delta t as, you can say, okay, so we know that delta x is equal to xf minus x naught. That's okay, and then delta t is equal to, I mean, you can just define this as delta t. I don't think you need to break it down really. So you already know that equals to 10 seconds. And now your solution is you just substitute these values to directly get your answer. So it's really simple. You broke the problem down in a very organized manner, and now you can get a really simple solution because now you know that xf minus x naught and then over delta t. So now you would get v average is equal to 10 minus 0 over 10. So V average is equal to 1 meters per second. So now you just solved one of your first kinematics problems on average velocity. And that is a very good example of how it will usually be when in a test paper or anything that you're trying to do. That's how they will usually ask you to find average velocity. Okay, so now that we understood average velocity and the definition of it, and we got a good understanding, we can move on to acceleration. Okay, so let's define acceleration. Oh, okay. Acceleration is defined as the rate of change of velocity. What that might mean is, let's say we have an object, right? So a circular object going like this, and you might be, so one situation that an object is moving in is, let's just say it's going with a constant velocity, right? So it has a velocity v, and what constant means is that that velocity is not changing, so it's just staying the same. So in this situation, because at t is equal to 1 second, v is equal to, it's just the same value, and then at t is equal to 2 seconds, because the velocity is constant, it didn't really change, right? So the object still has a velocity of v. So now the rate of change in the velocity in this situation was 0 because it didn't change at all. So in this situation, you say, okay, acceleration is equal to 0 meters per second squared. So that is the SI unit for acceleration, meters per second squared. Okay, so now this is just a basic understanding of what acceleration is, and this is a very simple example. But now let's say your object is accelerating, which means it's not moving with a constant velocity. So that's really important to remember. If an object is moving with a constant velocity, right? Let's just write that down. Constant velocity equals to 0 meters per second squared. So that means 0 acceleration. But let's say you have a non-constant velocity. That is equal to, you have an acceleration in this case. Okay, so this should be pretty clear now. Okay, so now let's explore the actual definition of the average acceleration that you can have in a situation. Okay, so average acceleration, just like how we wrote average velocity, average acceleration can also be written like this. And also, it is important to remember that because acceleration is describing velocity, it is also a vector, and a vector means that it has magnitude and direction. So a scalar, as we discussed before, a scalar has only magnitude, but a vector has magnitude and direction. So that's really important to remember because you might get a few questions asking you whether acceleration is a vector or scalar, and you'll get similar kinds of questions for previous definitions that we reviewed, which are velocity, distance, and displacement, but we'll go over that briefly just to summarize at the end of the video. So back to average acceleration. Average acceleration is given by the formula delta v over delta t. So as we said before, the delta tells us that it's the change in velocity and the change in time. So just write that formula down really quick if you need to. And we are going to do a little example now that we learned the formula. Okay, so similar example, just this time for acceleration. We can say an object is traveling with an initial velocity of 5 meters per second. Remember, that's the SI unit for velocity. So most of your problems will also have meters per second. And let's say it had a final velocity of 30 meters per second. Okay, and the time period for this motion was let's say 5 seconds. What is the average acceleration? Okay, so this is going to be our example problem. Okay. So let's start with the guess method again. So first we need to write down our given values. We know that it traveled with the initial velocity of, or let's just say I to make things simpler, initial velocity of 5 meters per second, and we know it had a final velocity of 30 meters per second. Notice that we're using the same subscripts as we did for displacement. That way it's much easier because you can remember I as initial and F as final. And then the time period is basically just delta t, the change in time, is equal to 5 seconds. And now what we don't know is our average acceleration. So we can put a little question mark there. And our equation that relates our unknown values to our given values to help us find the unknown values would be the average acceleration equation that we just discussed. So you can look back into your notes, something like that to remember, just to practice. And then our equation would be delta V over delta T. So our steps would be the same. You know that delta V is equal to VF minus V naught. And delta T is already implied, we know over here. Oh, I forgot the T. Okay, so now we're just going to substitute our values to A is equal to VF minus V naught over delta t. Okay, let's minimize that more so we have more space. Okay, and then we can say by substituting we get is equal to, we can substitute our VF, which is 30 minus 5 over 5. Okay, so it's always important to look back at your given information so that you remember what you're given so that you can substitute correctly. And then now we just do some simple subtraction and division to get that the average acceleration is equal to 5 meters per second squared. And it's always important to have the same units that as you were given over here. So because our whole question was given in meters per second and time in seconds and obviously the displacement in meters, we're going to use meters per second squared. Okay, so now that we got our acceleration problem down, we can do a quick review of all of the main topics we learned in kinematics today and how they are kind of related to each other. Okay, so first topic we talked about was distance, right? So we said that's the amount of meters between 2 points. So the amount of meters traveled between 2 points. So that can be, you could have traveled like this, like this, like this. It's just how you did this, how much meters it took you to do this is what matters for distance, right? And then displacement is where people get confused between distance and displacement. But in displacement, it doesn't really matter how you went from point A, you could have gone like that, to point B, because all that matters is the real distance between point A to point B, the shortest distance. So that's your displacement. So even if if a person traveled 100 meters between point A and point B, what really matters is that the shortest distance from point A to point B is 10 meters, and it doesn't really matter how a person walks or does anything. So that is your displacement. Right? Okay, so let's rewrite displacement. Now let's go to velocity. We know that velocity is the rate of change of displacement with respect to time, which gave us the average velocity formula of delta x over delta t, with delta x being change in displacement and delta t being the time it took for that change in displacement. And this formula leads us to the definition of velocity, which is the rate of change of displacement with respect to time, and then our definition for acceleration, which describes the rate of change of velocity with respect to time, which leads us to our equation for average acceleration of delta v over delta t. So for today's video, we briefly reviewed the definitions of distance, displacement, velocity, and acceleration. And it is very noticeable that distance and displacement are, first of all, they are often confused, but they are very different, and we can see that distance is a scalar, which means it only talks about magnitude, doesn't really care about direction, but displacement talks about direction and magnitude, which makes it a vector. Velocity is also a vector because it talks about direction and magnitude, and acceleration is also a vector because it does directly describe velocity. So these are all really main points to remember from today's video, basically kind of like a summary. And the main thing to notice about kinematics is that these are the four main definitions or topics that are discussed, and they are all connected to each other at the end of the day. We notice that displacement is kind of related to distance because it's the shortest distance between the final and initial positions. XF minus X naught, that's your displacement. It's kind of connected to distance, but different definitions. And then velocity is connected to displacement because it's telling you the rate of change in the displacement with respect to the time. And then acceleration is connected to velocity because it is describing the rate of change of velocity with respect to time. At the end of the day, it really ties back to the basics, and that is the basics of kinematics. Next video, we will go over the formulas and deeper understanding of kinematics in physics. Thank you so much for watching.